headquarters in Odense, Denmark. My name is Mads. I am product manager.
And my name is Rasmus. I am global tech support.
Yes, this is the first global Dploy webinar we are hosting. We have been looking forward to showing you Dploy, tell you a little bit about why we are doing what we do, why we have launched Dploy, what Dploy offers, and also give you a live insight into how the application flow is done, and to see an application here. In a second or a few minutes, Rasmus will take you through the practical part of the session. I will start off now with a brief introduction to give you a little bit of insights. It will take a few minutes. I guess what we are really here for is the practical part, so I will try to keep it short. Very good. If you would take next slide, Rasmus. So industrial automation has seen a tremendous growth over the past decades, but what is also still present in this space is barriers towards automation, and that is specifically for small and medium-sized companies. There are still barriers to automate in the form of time. It can be very time-consuming. It can entail a lot of complexity, lack of flexibility, and oftentimes it requires specialist knowledge that isn't necessarily present in companies. So this, I think I just had a mute. Breaking down these automation barriers is at the key of OnRobot's mission, and we have been working towards breaking down barriers for years with our one system, zero complexity portfolio of end-of-arm tools. It takes us only so far, so the next leap, both for OnRobot and for the industry, is Dploy. And yes, let's take it a step further. Dploy, the key of Dploy is making automation deployments faster, reducing complexity, and pass control over to end users without them having necessarily a lot of experience and specialist knowledge. So what we aim here is not only for manufacturers, but it's actually value creation across the industry with system integrators, with Dploy being able to deploy projects faster, creating more projects at a lower cost in less time, and with the same amount of people they have, they can now do more projects than they could in the past. And we know for this segment, especially recruiting and maintaining talented people is a key. So being able to do more projects with the staff that they have at hand is valuable. For manufacturers, they will benefit from this faster and lower cost implementation, while now also gaining control over the ongoing automation changes. If they have changes in their space, they are now able to do it themselves. If production changes, parts change, something change, they can now do it with minimum downtime to their production, and ultimately that leads to a better return on investment for deploying automation. Robots can now have less downtime because it's easy to reconfigure them if something is changing. While we do applications, the downtime in production is minimized. Lastly, for distributors and robot manufacturers, there's a benefit here from new market opportunities enabled by lower barriers for automation, and also there's a benefit of a higher general market growth. So in this whole launch of Dploy, we have done extensive research also to document the time savings that we can actually achieve using Dploy. And what we see is that for applications such as palletizing, for instance, we're actually able to cut off 90% of the time spent by deployment. And also, if you look to the right of the screen, in the redeployment, we are also making huge time savings with Dploy. And this, I would like to mention that this is not specialists redeploying applications. This is actually users that are able to redeploy and change their applications with this huge time savings compared to conventional programming. So what is Dploy? Dploy is the platform, and that means that we are binding several things together. We have some hardware components here that we'll explain in a second, but also Dploy is a platform that entails cloud connectivity. It enables us to be online, on-site, creating applications directly on the manufacturing floor. It enables us to monitor the applications that we have. It enables us to use cloud connectivity to do all the processing, meaning that we don't have requirements for having big, expensive hardware on site. We can actually utilize it. We can do it in the cloud. And as you will see with Rasmus showing an application in a few minutes, we're doing it on a tablet because Dploy runs in a web browser, so really you can access it from the device you have at hand, also as a part of lowering the boundaries for automation. And further, this also means that we now have the capabilities in the platform to actually make the robot path plan by itself in the system. So it's not something, we are reducing complexity by utilizing this whole platform to control a combination of hardware and also all the processing required. So we have some hardware components. As I mentioned, we have to start with the OR base, which is sort of the brain, you can say, of the hardware components here. This is where you access Dploy through. This is where you connect the robot. This is where you can interface with digital in and outputs. And that is sort of the key component that you need in order to run Dploy. Then we have a series of other modules that is easily configured to the OR base with a mechanical lock in the side. We have these two modules currently, the OR machine, which is a contactless relay to interface to machines. And also we have the ORCOM module, which enables us to have wireless connectivity, either in the form of GSM connectivity via SIM card or using a Wi-Fi signal. Yeah. So what Rasmus will show you in a second, we have limited time today, so unfortunately we can only do deep dive in one application. We have chosen packaging for today, but what you will see is that Dploy is a very intuitive flow, and that is a flow that is the same for all 4 applications we have launched with Dploy earlier this year. We have 4 applications now. We have CNC machine tending, we have palletizing, packaging, and transferring, and everything utilizes this same platform, the same user interface, same cell setup. So once you have your cell set up with the robot and the required elements, you can go ahead and choose whatever application type you would like. Then you select the workspace. If you have obstacles you need to be mindful of, especially for CNC machine tending, this is relevant. You can easily do that. It takes you through the application flow, lets you know if you are needing to still configure some things, if you need to add elements, and then you're ready to operate and monitor your application. And also, of course, redeployment is again back to the application flow, and you simply do according to the changes you might have. So a last thing before we'll go to the practical part of the session. For packaging, we have a good example of how intelligent Dploy is in computing the robot path planning, and that is what you will notice when we package some products in a container, is the Dploy automatically takes into account the confined space we have here. We have sides on the container, we have some products maybe already in the container. Dploy automatically creates a path that takes all this into account, and what you will see is that as we fill parts in the container, the robot will sort of tilt based on these different placing strategies, tilt the part in so that we avoid having collisions between the parts in the container. And of course, this is something that is, if you change dimensions of the part, we recalculate all the path planning, and you will see that the strategies adapt to whatever changes we have. And this is really key. This is for all applications, but this is absolutely key to reducing complexity and eliminating this specialist knowledge for redeploying applications at the end user site. All right, that was all for me in this. Just to mention, we will have a Q&A at the end of the session, so please don't hesitate to write your questions. There should be a question bracket, and we will take them by the end of the session. All right, and we have a tablet here. We will just make that the center so that you will be able to see how things are going off. Let me just share the screen here. Normally what you do when you start with Dploy inside the OR base, I have one just over here, just a second. Inside the OR base, when you configure that, there is a QR code inside the lid. You simply scan the QR code. There are two QR codes. The first one logs you to the local network of the OR base, and the second QR code takes you to the web browser. We have already done that with the OR base we have down here. So yeah, it should be ready for you to take us.
Okay, I'll take it from here. So I will start by sharing my screen, and then I will go to Dploy. This is the screen that you get to after you have logged into Dploy. This is the cell configuration, so every element that is in the cell is configured in this page. The tools that is attached to the system will be automatically detected and shown in the tools list. The robot can be also detected as well when it's connected, and will show up in here. What's left is to define digital inputs and outputs if needed. So in our case, we have defined a in-feed sensor. We can see where it's connected to the digital input 1 on the OR base. That is the sensor that tells us when a workpiece is ready for picking up. Then we have interlayer sensors. That is for the interlayer table here, showing if we run out of interlayers to use. And finally, an outfeed sensor. That is for detecting the container that we have here behind the robot. The output right now is specified as green light. That is because it's a green diode that is connected down here. This can be used for events in the applications. So if there's something happening in the application, if we run out of in-feed trays, if the part is dropped, then we can use it as a signal for an operator to intervene with the machinery. So this is the first step, defining the parts, defining the setup, and that's it. Then the next part would be going into the workspace to define if there's any boundaries in the workspace that we need to take care of. In this application, we are picking up boxes below the table, and the fastest way to the box here, where we are going to place the parts, will be through the table. So we have defined the the edge of the table. I'll just zoom in on this, and then I will specify this box. This box number 1, that would be the edge of the table. The small box number 2, that is the corner of the slip sheet table here, and that is put in to avoid collisions with these parts, because that is in direct route from where the robot is picking up parts to where it's placing parts. Once we are satisfied with all of that, we press the save button, and then we press finish, and then we are taken into the application view. Just to make this a little bit faster, we already set up an application that we will run through how it is built. So I will go into this packaging demo session that we made, and you can see all the steps are already here. They will be generated one by one when we're doing the application. So the first step will be the gripper. If we have different selections for the gripper, that could be different customizations that are put in, then it is possible to select them here, and then all the points will be updated accordingly to that setup. If we only have one, we will skip this step, and then we'll just press done, and then it will jump to the next step. So the next step will be defining the in-feed. In our case, we can do single and dual pick because this gripper has the option to take several parts at a time due to the different channels that are in the VT tool. We can specify the position. That would be this. Right now it's written as reteach, but it could be the first time we're going into it. It would be a teach. We can use the small arrow pointing to the point to go to that position, so I'll just press the auto move from here, seeing if I can get it to move. I'll just try to move the robot a bit. It is not playing nice today.
This live has to be like that.
It's a live session, yeah. When it's operating, then we can use these points to go to the position. We can specify the shape of the product. In our cases, it's these small boxes that are coming in. We're putting in the dimensions for those, specifying that it's a center pick that we're doing, and the weight of the box. Then the kinematics of the robot will be updated automatically, so it will change between different center of gravity, different payloads inside the program. No need for the user to do anything besides typing them here. There's illustrations to specify how to actually do the dimensions, so the A, B, and C are drawn according to the tool that is used, so it's easy to specify. And once everything is done here, we can test all the sub-steps. Let's see if that works. We have an approach with an obstacle. Perhaps I moved one of the obstacles when we were in the workspace. We will see when we get a little bit closer, otherwise we'll go back and delete it. But that is supposed to work here. Then we have our container where we are going to place the outfeed. And in this setup here, we have already specified it. Where is the container? That is the container. Sorry, I double pressed the buttons. We specify how large it is. We specify where the corners of the box is. So all the user has to do is to pick up a part and place it in the three corners, red, blue, and green, and then it is possible to calculate the box based on that. We can choose different strategies for filling the box. We can either take the fill container, we can do a number of parts, or we can do a custom. If we do the custom, then the small pencil icon on the image will take us into a view where we can select how boxes are placed, if we want to rotate them, if we want to have different patterns for different layers, then it's possible to do it in this setup. Once we are satisfied with how the pattern is, we press save on that, and then the pattern is generated here. Then we can make an interlayer step if we need to have interlayers in the setup. Then we simply teach two positions. We teach the pick position where it's going to pick up slip sheets, and then we put it inside the box and make a place position. Then we automatically calculate how the rotation of the slip sheet is and how to avoid running into any obstacles in the workspace when we are navigating with the robot. So once everything here is finished, we press done, and then we have the pattern update. Then we have to validate the pattern. Then all the information that we have typed in is sent to the cloud. The cloud is calculating how to do this and sending it back. And if we have something like here, where I moved one of the obstacles, now I get an error that the pick approach position is in collision with the obstacle 1. So it cannot go from that position into to obstacle 1. So we get an error code saying what is wrong, and then we get the option to go back and correct it. So I'll just do that. We'll go into the workspace, and this is probably the one that I messed up. So I'll just move it back and say that was it. Go into my application again, revalidate the pattern to see if that solved the issue. And now it says pattern valid. So I'll press done, and I will finish the setup. Then we get an option to save and test the application that we just created. or we can simply save and exit. Save and test is for running it with slow speed in the beginning, so we can see that we don't have any collisions. So I will do that here. I'm in the mode where it can, where I can run the program in test mode, and it automatically suggested that I ran it in reduced speed. So I will start the program, and I will start a new run. Oh, sorry, I'll just show you one more. Here we have the option to select if we already did some of the packaging, so we're starting from a fixed point. That could be the first 7 boxes are already placed inside the container. Then I could start from that point. But here I will start a new run. So first I will be asked to move into the home position of the robot. That is where it's going in between cycles. And then I can run the application. So let's see. Now we have specified that the area is clear, and it's going to, first of all, go down, be ready to pick up a part. And now it's waiting for the container. It's specified, and that's because it's not put into the sensor. So I'll do that. Then it's starting, and now it picked up a box and is placing it into the container.
Did we switch to camera views?
Yeah, let's do that.
I think, yeah, we're still sharing screen, aren't we?
We are sharing both, I think. So now we'll just do a close-up on where it is placing the parts. And then you can see the tilt motion when it's trying to position the boxes in the corner. We'll just take one more to show it. And it's tilting towards 2 corners this time to make sure that we don't collide with the boxes when we're trying to fit it into the container. While we are running this application, we can see how much time is left in the application until the container is filled. So we can keep that in the monitoring. Yes.
Good. Also in the cell setup, we had, as Rasmus mentioned, various options for sending output signals. So Dploy is able to interface with whatever systems you have in your workspace elsewhere. So let's say we want an output signal to be sent when the container is full. If we are running palletizing, we want to know maybe a little bit in advance before the pallet is actually done. We want the signal to be sent to an operator. All this is configured in the cell setup in the same flow, no matter which type of application you're doing.
Okay. We will switch back to the overview of this camera position, and I'll just stop the application. This is how it is run. Once it's done running this, it will set signals, as mentioned, so that an operator can pick up the box, or that we can signal a conveyor to move it along in the application. But as Mads mentioned in the beginning, all the different steps inside these setups are the same. So I'll just save this one and exit it, and then I'll go back to the application and show you a different application.
Just as a service information to you, Rasmus, 5 minutes remaining. So
we'll do it very, very short.
Yes, so we can have some questions.
Okay. This is a palletizing application, and for palletizing we require that we have a pallet station in the setup. That is not set up right now in the cell, so I can not validate the flow, but I can still show you that the steps are exactly the same. First step, selecting the gripper, what type of customization is there. Second step will be the infeed position. Where is the infeed? It's the same. Define the boxes dimension that we are going to pick up. We can even set, if we have a label on that is supposed to be scanned from the outside, then we can select that as part of the setup here, and we will automatically calculate a pattern where the labels are outside. We can specify the outfeed in this setup. Just jump a bit fast. In this setup, it would be a pallet instead of a container that we are placing them on. But it's very, very fast, very intuitive. We can select different standard pallets, and we can select custom pallets if that is needed. And finally, we can do the pattern as well. It's the same. We can all do automatic patterns, or we can do manual patterns, customized patterns if needed. But yeah, I cannot validate it as I don't have the right sensors in the equipment, so I'll get a warning saying that is not possible.
Just to show maybe, what we can do here is also, if we had the pallet station, let's say we were to do, I don't know, 6 layers. Now we're not able to validate, but since we have the cloud, it means that all the computation is sent to the cloud, so validating 2 pallets with each 8 layers takes a minute and a half, 2 minutes, something like that, a little bit depending on which robot we're talking about. But it's just to emphasize that this whole online, on-site, the capabilities are now there, so you don't have to spend a lot of time doing all the computation at home before you actually go there. You can now do it online, on-site, as you want to set up the application.
Yeah, and as you saw the validation step before, that is the entire send the information to the cloud, do the calculations, make an application. That would be a couple thousand lines of code, and then send it back to execute it directly from the OR base.
Maybe one last thing before we go to questions. Could you show the jog screen?
Yes,
we have not done that too much today. Yeah.
When we are going to move a robot around, we have this jog screen. That would be the small joystick button in the side panel. If we press that one, we get to this jog screen, and then we can either jog in, right now we're jogging in base, where we can move the robot around, or we can switch it to tool coordinates, and then we need to know how the tools is actually oriented. So if I move it in tool, then that will be what is operated here. We can switch and do direct movement to joint configurations of the robot if we want to do that, or a specific position in the workspace. Or we can do one of the smart features and auto-align this tool so that it will align the tool with the X and Y coordinates of the robot for easy maneuverability of the tool. It's also possible to do inching, so we specify exactly how far does the robot need to move every time we press a button. So I'll just press it one time, and then I will move these 50 millimeters that I'll just put in.
And again, as a way to lower complexity, this jog screen and everything else is identical despite what robot brand is actually configured with your Dploy cell. So that's again a way to lower complexity. If you're used to only one robot, you don't no longer need to know a programming language, because we simply eliminate the need for programming with Dploy.
Yes.
I will just jump over to questions.
Let's do that.
Here. I do know how to maximize this question bar.
Oh yeah, sorry, 2 seconds.
There's quite a lot of questions already. I think, Rasmus, we are open to stay a little longer and answer some questions.
Yes.
So hopefully some of you are open to the same. And Rasmus is now browsing through the questions. Do you want to read a few, or should I take that?
Oh yeah, will you take that part?
Yes.
I will gladly answer the technical part of the questions.
So we have a first question here. What happens when the license expires?
So what happens when the license expires? When the license expires, it is no longer possible to create new applications. Then it loses the ability to generate new applications.
Exactly, and I think we haven't quite covered that, and I mean, given the time, we don't have the option either, but Dploy is a license-based platform. It is required to be online, on-site. That is, with the license, the same. You require internet connectivity in order to create applications, because the computation is done in the cloud. But let's say your internet connection gets lost, the robot will simply continue doing what it's doing because it's already in Dploy.
Yeah, we are only using the cloud connection to calculate the application and to send up metrics from the application to the monitor part of it. It is not required to run the application. You can run the application offline.
Yeah. We also have a question about logics and how many digital inputs and outputs are offered with the different modules.
Yeah. On the OR base, there is 16 inputs and 16 outputs, and if that is not enough, it is possible to increase that number by using a machine module together with the OR base. So that will give you an additional, I can't remember, 8
of each.
Of each.
Switch camera here just to show you this is how the front of the OR base looks without the cover. There's a series of these small bars for configuring all the signals. They're all coded. Also, you have the LED lights for communicating. The OR base communicates once it's up and running, etc. All right. Is the process meant to be done on site, like I don't need an offline preparation?
Yes, that is the purpose of Dploy. The idea is that you don't need to make any preparations, you don't need to make any simulations. You go, you set it up, connect the digital inputs and outputs, and then do the calculations on the fly. In our case, we ran into this problem that the obstacle was not defined correctly. We got this warning that something was blocking us from doing the application. We went back into the workspace very, very fast and moved the application back to where it was supposed to be, and then did a new calculation, new programming of the entire cell on the fly. Very, very easy, very on-site.
It's also a question if the webinar is recorded. It is recorded, and you will receive an email after we finish where you can access the recording.
Yes.
Rasmus, we also have a question whether Dploy is open source, and if we allow developers to develop APIs into Dploy.
No, that is not the intention.
Yeah.
So the Dploy software is not open source, and we do not offer APIs into the system. The way to connect this to external PLCs will be through the digital IOs.
Yeah. We have a question on robot compatibility. Which kind of robots are compatible, or if we have any restrictions in that regard?
Yeah, so right now we have several brands that are compatible with on-robot Dploy. They are listed in the software. I think we have an overview somewhere. It is, I can't remember the number of brands on top of my head, but we have the kinematics model of all the robots, and then we use those models to calculate how the robot should move and how to avoid collisions with objects in the workspace and collision with the robot itself. But we need these models of the robot for it to work, so it's not an work on all brands. Yeah. But currently
we have seven brands.
7 brands
supported with the first Dploy.
Yeah, and several models for each brand. I think 10, 20 models for each brand, almost.
And this is a portfolio of supported robots that we are expanding continuously. We have the first new release with new robots, Kawasaki, Yaskawa, Yaka coming up in a very short notice. I think we have, before the end of the year, we'll have another 7 or 9 robots supported. So it's something we expand on continuously. We have a question to data. How much data is held in the cloud, or is it just when programming?
So how much data is held in the cloud, or if it's just programming? While we're doing the programming, we will send the position information that we have calculated from the robot doing the application to the cloud, then doing all the calculations in the cloud and sending back the program code for executing the entire application. I don't know the size of it exactly, but it's very limited. What we then do if we have a cloud connection is to store metrics from the application. So inside Dploy we have this monitor where it's possible to go in and look at the application, how it's performing, how many cycles it has done during the day, how what is what is the cycle time. If there's any wait time, we monitor some of those as well.
Yeah, exactly. I mean, monitoring is a whole session for itself.
Yeah.
But we have, as part of Dploy, as Rasmus say, it's a part of the platform where remotely the administrator is able to go in, monitor the KPIs, set up custom dashboards for each cell, or to have a general factory overview and so on. So it's to my knowledge, there's no limits. I don't think anyone would ever be able to expand or breach the amount of storage that we actually supply. And the same goes for the application library. We don't have any upper bar, realistically speaking. There is a question here, do I need to use the user interface of the robot or the teach pen in parallel to using Dploy?
So if we need to use the teach pen and not the robot?
Yes.
Yes. There will be a first-time setup where we are connecting the robot to Dploy. The Techman robot that we have here is a very small program. You make a listen node that listens to itself and start it as an automatic program on the Techman. Once that is done, you don't need the teach pendant anymore. For some of the other robots, it's even more simple. You just hook it up and then we take control if the robot is enabled in auto mode or in remote mode. For some of the robots like the Doosan or the Fanuc, you need to install a small script first time to get access to the robot. But once that is done and that script is started, then everything can be done from Dploy.
A question regarding possibilities of using non-on-robot end effectors in the farm tools.
Yeah, using a non-on-robot end-of-arm tool is not an option. We need to know the size of the tool and how it is configured, how it's operated to do these obstacle avoidance calculations. So that is part of the on-robot platform. What we can do is customize the tools, so you can put on different extenders than what we are showing here. You can change the fingers on the finger grippers to something and specify it in the application that we are using custom fingers. But it's not possible to use a third-party tool.
We have also a question regarding integration of camera into Dploy.
Yes, work is in progress of integrating the on-robot eyes into Dploy so that we get the vision capability included in Dploy.
Yeah.
But again, not a third-party camera.
There is also a question of whether Dploy can learn new procedures or new applications. As I understand the question, right now, as we mentioned, we have these 4 supported application types. Similarly to how we are introducing new robot models and brands continuously, we are also launching new applications with Dploy continuously. This year we will launch at least 3 new applications, I believe. And that is something we will continue to do to expand into more and more applications. And everything is going to be in the same Dploy flow, and everything is going to be accessible for people also who already have an OR base. We didn't show that either, but simply when an update is pushed to the OR base, it can be accessed through the cell setup and is updated by a click of the button.
Yeah. And when you update the OR base, so you get new applications or new path planning strategies, then everything is backwards compatible. We will not change anything unless we go in to revalidate the pattern. So you need to actively go in and say, I want to update my program with the new features.
There is a question regarding the inching. Let me just find it again. So is it being initiated through the cloud? And if so, is it a secure connection that cannot be breached?
Yeah, regarding the inching. The inching is done directly from the OAuth base to the robot. There is no cloud connection for the inching. The cloud connection is only for calculating the entire application and for sending metrics about the running applications. It is not for moving the robots. So no, it cannot be breached. Yeah. It is something that you send from the application. If you're inching very, very slow, we even have the possibility to stop the current movement directly from the teach panel.
And just on the security aspect in general, we have launched a IT security white paper. As we know, it's of course a concern for many. We have had extensive testing of connectivity and cybersecurity in general, launching Dploy, and right now Dploy is as secure as anything physical. We have done a lot of safety precautions and measures, meaning that it is almost impossible to breach, but we have a white paper if anybody is interested to do that. We have also, I think will be the final question, if Yaka is supported?
Yaka is still not supported.
No, but will be within the year. So I think we will thank you all.
Yeah, and end the session for now.
Yes. Excellent. Thank you very much. Have a good day. Have a good night. And thanks for attending.